Well, good morning, everybody, and welcome to the second BVK brunch. And we are going to be talking about the body voltage kit from EMFSafe and how to use it and how to assess the EMF in your situation, in your home, in your office, and then the various things that we can do to mitigate and reduce our daily EMF exposure. Because even though as important a concern in mitigating EMF, reducing the radio frequency from our phones and Wi-Fi's and things like that is. That's definitely important. But the elephant in the room is the electric fields, because all types of EMF are cumulative. Electric fields, magnetic fields, radio frequency, and the dirty electricity, which a lot of people are concerned about, is really nothing more than an artifact, a harmonic of the 60 hertz. And if you filter out all of the dirty electricity, you've still got the 60 hertz. And it's the 60 hertz that probably is the single largest contributor to EMF exposure for most people on a daily basis. So by taking out the or reducing the electric field, you are significantly reducing, we estimate, by just reducing that at night down to 100 millivolts or less, if you can do it, you can reduce your daily EMF exposure by as much as 70%, which for most people is very, very significant. And we've seen a lot of people with various symptoms see, rather than getting a little bit worse every day, suddenly they start getting better every day, which of course is what we want. We want to be functioning in a healthy way. So this is our website, liveemfsafe.com. liveemfsafe.com. This is the homepage. Really, this picture sums up exactly what we're trying to do. For many people, being exposed to EMF, or when they get concerned about EMF for the very first time, it's a smart meter that gets added to the house. It's a cell phone tower that gets put up in your neighborhood closer than it was before. And all of a sudden, people become aware of the effects of EMF, or they put two and two together and make the connection between whatever symptoms they're having and the EMF exposure around them. And so they assume that whatever that straw for them is that breaks the camel's back, so to speak, that straw is the problem. But the straw that breaks the camel's back is not the problem. The problem is that the camel is loaded. And so what we're talking about doing here is unloading the camel. And then whatever that thing is, if it's a cell phone tower, there's really nothing you can do about it. Sometimes you can get rid of the smart meter, but that's not the cause of the problem in and of itself. It's the cumulative load of all of the EMF that you're exposed to. And there's a lot of EMF that we're exposed to that we have absolute control over, and that's what's going on within our house. So that's kind of the gist of it. Now, as far as the body voltage kit goes, if you click up here on more pages, we've got blog posts here, lots of useful information. About fact is about the actually, let me show you this one, because this is kind of funny. This is Dan. He's the CEO of the company, and this is a video that we shot. Dan is touching the toaster over here. It's not on, it's just plugged in. You can't hear the sound, or maybe you can, but this is the E-pen that came with the body voltage kit. And then I come in here at the end. And so and Justin there and myself, and the E-pen is beeping and flashing. The electric field coming from the toaster is going through Dan's body and making the pen go off. And then as each of us join in the line, the electric field is going through each of us and the pen goes off. Now, if you've got skeptical family members, using the E-pen to show them the effects, that the electric fields are there, and then that they do go through you, and then you can set up a daisy chain with members of the family. It's a lot of fun to do, and it lets people, suddenly they realize, gosh, this is a problem, this is an issue. Because if you're laying in bed and you've got an electric field going through your body all night long, it doesn't take a rocket scientist to figure out that you're probably better off not having that going on, interfering with your sleep. So and then a little bit of information about all of us and FAQs and stuff like that.
Anthony?
So, yes, go ahead.
So the E-pen doesn't give you any kind of specific reading?
No, the E-pen does not give specific readings. It is just telling you that there's an electric field present. And if you get within 2 to 3 feet of something putting out a field, the pen will start going off. It's that sensitive. The difference between our pen and other pens on the market is electricians have been using these things for years. They have a pen you normally have to stick the pen into a socket, and then if it's a live socket, it goes beep, and they know that if they flipped off the breaker, they didn't flip off the right breaker before they put their hands in there. And obviously working on a circuit, you don't want to get electrocuted, or you need to be particularly careful if you're working on a live circuit. But our pen is so sensitive, it will actually pick up a field 2 to 3 feet away. And then you use the body voltage kit, the body voltage meter, to actually measure and quantify that field. Now, the other thing the pen is extremely useful for is finding hidden circuits in the wall, the floor, the ceiling. If you turn off the circuit breaker to the room, like in this picture here, you've got wires running through the wall. Let's say we turn off this circuit, which is the plugs, and you still got a high reading. Well, where's that reading coming from? If there's nothing on around you, well, maybe this wire here running directly underneath the bed going outside to something in the garden is still live. So if you take the pen and you just draw a circle, turn down the sensitivity, and you just basically draw a line on the floor with the pen around the bed, and all of a sudden you get to here and it goes beep, beep, beep. And you say, oh, there's another circuit down there. And what you can do is just leave the pen on the floor, and then whoever is helping you at the breaker panel goes through the breakers. And as soon as the pen stops beeping, you know that you found that circuit. Of course, if you're holding the body voltage meter, then the field is going to drop down as well. So you've got a double indication there. And also you can use the pen to find out if the circuit's coming up from below, if the wire's going up into the ceiling, or if it's going left to right. So it's a very useful tool to have. I'm going to play this video for you.
Hi, Anthony here with EMFSafe, here to talk about our body voltage kit. When you order one, it comes in a package like this. And inside you'll find the E-meter, the E-pen, the circuit safety tester, and all the cords that you need, as well as a trifold containing the instructions for use. The E of EMF is the electric field. It is also the elephant in the room. And with our E-pen, you can now talk about the elephant in the room, electric fields. To turn on the E-pen, simply turn the dial on the side. The lights will flash and you'll hear a sound when there's an electric field, because electric fields aren't just in a room, they will actually go through you. And in this example here, as soon as I plug in my iPad to an ungrounded cord, the E-pen goes off, alerting me to an electric field. So how strong is that field? For that, you need the E-meter. But before you hook it up, you need to test to make sure you have a safe ground. Once you've done that, you can plug in the ground cord. And then to hook up the meter, simply follow the instructions. You can pause the video if you'd like to read through them. There's a number of ways to hold the E-meter. You must come in contact with the metal, so either one of these methods works perfectly well. Remember, E-fields are everywhere in your home, and it might be difficult to find a place where the pen doesn't go off, and it's all the things added up together that contribute to your load. Having a body voltage kit will help you reduce that load and be EMF safe.
I'm holding the E-pen now and it's on.
Right.
Blinking red. And I'm right in front of the laptop. If I press it, I get a white light.
When you push the button, all that does is it's making the light go off. If the dial on the side here, if you click it once, that is the most sensitive setting. And then if you turn it down, so if I wanted to find wires in the wall, I'd turn it down. I'd find a extension cord on the floor, and I'd turn down the sensitivity so I had to be within like 2 or 3 inches of the wire before it went off. Otherwise, I've got a light, a near infrared light on behind me, Actually, that's coming from my iPad because my iPad is plugged in. Now I'm going to unplug my iPad, and now the pen isn't going off.
Got it.
So I can get right up to the screen. But if I take the power cord here, and if I plug it into my iPad, that's about 3 feet away that it starts going off.
Okay.
So there's an indication there of the strength of the field. This is designed to detect electric fields to know if there is one there or not. If you go to a restaurant and you sit down and you get the pen out of your pocket or your purse, ladies, you turn it on, and okay, if I'm going to sit here for 2 hours and enjoy a meal and a conversation with a friend, I'm not sitting in an electric field. If you sit in a booth and you turn this on and it goes off and you go, oh, and you look down, there's a plug right down by your feet, or a heater unit or something that's turned on. You know, you say, excuse me, could I have a seat in the middle of the room? And you can sit in the middle of the room and not be sitting in an electric field for 2 hours while you enjoy your meal. So you can go to a friend's house. You're going to sit and talk or watch a movie. You sit in the sofa and there's a light right next to you and the pen's going off. If you sit in the middle of the sofa and you put it to the left and the right and the pen doesn't go off, there's still going to be some electric field. There's going to be some EMF, but you are on a significantly reduced level of EMF. And so you can just sit there and have your conversation and enjoy yourself, especially for sensitive people. It just helps them on a daily basis be in situations where there's less EMF rather than more. So it was brought up earlier, the most important is to use the circuit tester. You may find you don't have a ground, in which case the body voltage kit won't work. A very, very important point is when you turn off the circuit to your bedroom, let's say you're checking your bedroom, you've checked the circuits, you get 2 yellow lights, no red light that tells you the wiring is correct. You unplug this and you plug in the ground cord, which is this one. Some of you have body voltage kits with black cords or red cords. Most of them have the white cord. They all work exactly the same. There's no difference. So this goes into the ground socket, and then this end goes into the body voltage meter. Maybe you've got a metal frame on your bed. You can plug this in the ground, and then you clip the crocodile clip, the alligator clip onto the bed frame, and sometimes that helps reduce the field as well. But when you disconnect that circuit at the breaker panel, so now the plugs don't work, maybe the lights don't work, you have not disconnected the ground. So all you're doing when you flip the breaker is you're disconnecting the power. The neutral is still connected and the ground is still connected. And if you choose to take this to the next level and get a EMFSafe cutoff switch, then we have 2 types of cutoff switches. One is just the power only, and the other is the power and the neutral. And the reason we offer that is we are told by people who are EHS, electromagnetic hypersensitivity syndrome. These are very, very sensitive people. They can tell if you have a cell phone on you or not, if it's turned on or not. They're that sensitive. When they turn off the breakers, obviously it's a big relief to them. But when they get one of our EMFSafe cutoff switches with a neutral and power disconnect, they can tell the difference. They tell us that is an even better improvement than just turning off the power line itself. When you turn off the power and the neutral, that's even more relief for people that are that sensitive. So we do recommend the neutral power disconnect, but it's better to get power only than not get anything at all. So yeah, I think the instructions are pretty clear. You turn the red dial from off to the V position, and you'll see a V down here, and then you push the red button once, and that goes from DC to AC. I don't know if you can see that on the camera, and that's the reading. So I'm sitting here in my home office, and I am getting a body voltage reading of 78 millivolts. So you want to be below 1,000 millivolts during the day, if you can, at all possible, in the kitchen, or definitely in a work situation. If you have a desk, try to be below 1,000 millivolts. And you can achieve that by turning things off that don't need to be there. You don't necessarily need the printer on all day. You can just turn it on when you need it. If you need it on all day, just move it to the other side of the room. You need the exercise to get up and cross the room. It's healthy to do that.
Anthony,
yeah, go ahead.
So on the reading on the meter, you say you want to be below 100 millivolts. That's 0.1.
That's 0.1. Yes.
Got it.
So 1.0 is 1 volt per meter. 0.1 would be 100 millivolts. 0.1 volt or 100 millivolts. So we talk about millivolts, but that is the number behind the decimal point. Yeah, very good question. Thank you.
And then what's the reading you're looking for at night, like in bed?
At night, you want to be below 100 millivolts. So it should say 0.0 something. 0.090 would be 90 millivolts. The Building Biology Institute recommends, they say a body voltage reading at night of below 10 millivolts is of no concern. I've never seen 10 millivolts. So rather than giving somebody false expectations and being frustrated because they could only get down to 20 millivolts, it's better to feel good about your 20 millivolts than be frustrated. And realistically, in the modern world, if you can get below 100 millivolts, which Building Biology Institute say is of slight concern, anything above 1,000 millivolts at night, they say is of extreme concern. So you definitely, and we have found often, very rarely before mitigation, very rarely do I see a reading below 1,000 millivolts in somebody's bedroom. And I have seen readings of 7,000 millivolts.
Is that basically when everything is unplugged and nothing's on, that you'll get that high of a reading?
No, that's before we start. So that's with everything plugged in. That's with their clock, their phone charger by the side of the bed, which may or may not have a phone plugged into it, but the cord is there. So, okay, now I'm touching the metal under here with my thumb. So actually let me hold it this way. Now, here's the power cord. 34,000 millivolts. I let go. That's 900 millivolts because I'm holding on to the cord. If I let go of the cord, 60 millivolts.
And so you turn, just to get the dial right, you turn one notch to the left of the off.
Yeah, where it says V.
Got it.
V for volts. We're measuring volts and we're measuring AC, not DC volts. Now, getting a DC reading, I'm not concerned. All of these devices that run on battery, your phone, we're concerned about the phone because of the Bluetooth and Wi-Fi, which are 2.4 gigahertz, exactly the same frequency your microwave oven uses, 2.4 gigahertz, exactly the same frequency as Bluetooth, 2.4 gigahertz. Give or take a few frequencies, but basically right in that area. So your microwave oven, your Wi-Fi router, and the Bluetooth, if you have a Bluetooth mouse or keyboard or headset, heaven forbid, that's sending a 2.4 gigahertz signal through your brain the whole time you're wearing them. That's the same frequency your microwave oven uses to cook with. Now, the power is much less, but the microwave oven 10 feet across the room from me, when I put in my coffee and heat it up and walk away, I'm 5, 6, 7, 8, 10 feet away. And of course, the microwave oven is a Faraday box designed to keep the microwaves in the box. I mean, it doesn't do a perfect job. You don't want to stand in front of a microwave oven when it's on. But 4 feet in front of a microwave oven that is on gives exactly the same reading as 4 feet from a Wi-Fi router. So if you're sitting 4 feet from a microwave, from a Wi-Fi router, you may as well be standing 4 feet from a microwave oven when it's cooking. And if you don't use a microwave oven because you know it's bad for you, we've all heard the stories about microwave ovens. Well, having a Wi-Fi router sitting on your desk or in your bedroom is like having a microwave oven on all the time. You only use your microwave oven for 5-10 minutes, maybe 20 minutes if you're heating up a dinner or something. But the Wi-Fi router's on for some people 24/7.
Right.
Or if you're sitting in your office for 6-8 hours, it's right there next to you. Not a good situation. That's definitely something that needs to be hardwired. Or you can put up a shield, something like this, Reflectex. This is Mylar. It's metallic on both sides. And then you've got bubble wrap in between. You can buy this from Home Depot or Lowe's. And if I'm sitting over here and I have my Wi-Fi router, or if you have to have your phone on, maybe you're in the medical field, or you got a family member that might be calling you at night. If my phone is here on my bedside table and I'm over here, then I'm being protected from the signal. I'm not getting zapped all night long. If I have to have a Wi-Fi router on and it's protected by the Mylar, and the Mylar is between me and the Wi-Fi router, I'm not getting zapped by the Wi-Fi router all the time I'm sitting there. This is one of the tips. And if you go to the office page on the website, it gives you all of these tips and ideas about how to mitigate your home office. So the number one place that we are concerned about is your bedroom, because we're 10 times more sensitive at night than we are during the day. So that's why we want below 100 millivolts at night, and then below 1,000 during the day. Bedroom, number one. Office, if you're there for 6 to 8 hours, home office or work office. And then number three is what I call the happy chair, which is where you sit and watch TV, eat pizza, visit with your friends. If you're going to sit there for 2 or 3 hours in the evening watching a movie, or enjoying family or company of a friend, let's not sit in 2,000, 3,000 millivolts if we can get it down below 1,000 millivolts or 100, or like I'm sitting here, which is where I sit to work, and I'm below 100 millivolts sitting here. So, I've worked on setting up this particular situation. That's actually, I'm in an RV, a fifth wheel, for that very reason. That's where my office is, because, all the lights are 12 volts. I don't have to worry about radiation coming down from that. And the 60 hertz circuits in here are extremely limited. So, choose where you're going to work.
Right. What was the product that you used that we could get at Home Depot called?
Okay, well, there's a number of things you can actually use aluminum foil, just regular kitchen foil. This is Reflectex. It's a product called Reflectex. It's used for insulation, and it's Mylar on both sides. And this between you and the Wi-Fi router will reduce your RF exposure by about 90%, 90. If you're in a duplex or an apartment and you share a wall with somebody and you've turned off everything in your place, and maybe your neighbor, if you're laying in bed with your head up against the wall and your neighbor 12 inches on the other side of the wall has their Wi-Fi router right there, 12 inches from your head, that's coming through the wall. You're being zapped all night long. Maybe they've got a flat screen TV, or maybe that's the head of their bed and they've got a lamp there putting out an electric field. So if you put this up behind the headboard of your bed, that's going to block, it's going to absorb the electric field. Now this has to be grounded. So I would put this up. This is going to block 90% of the RF from coming from their apartment through the wall, but it's going to attract the electric field. So if I clip the alligator clip on here and then ground it, the electric field follows the path of least resistance. So now it's going to ground. So I'm not getting zapped with the electric field coming off of their flat screen TV or their lamp or their Wi-Fi router. And it's blocking the RF coming off of their cell phone on their bedside table their Wi-Fi router that's on their bedside table, which unfortunately it probably might be for them, but it doesn't need to affect you. And all you need to do is set up a shield. You can also use a screen, metal screen. If you think about the metal screen on the microwave oven, that's stopping the microwaves from coming out. That's called a Tesla screen. And the holes in the mosquito netting that you can buy for screen doors, they still sell the metal stuff. 90% of it's plastic. Be careful, don't buy the plastic for shielding. Buy the metal stuff, which is made of either aluminum or stainless steel. And then that will block, again, 90% of the RF coming in, but then you need to ground it so you're not exacerbating and making your electric field exposure even worse. So that's how we mitigate a bedroom in an apartment situation. You may have to put some underneath the bed to block the electricity coming up because their ceiling is your floor. And if they've got their lights on, you can have electric field coming up from underneath. In some older apartments, they don't have metal clad wiring. I had one situation where it was an old apartment in Sausalito in the San Francisco Bay Area. And the power for the apartment upstairs went right underneath the bed of the person that was trying to mitigate their room. So they didn't use the Mylar, they used the metal screen. They laid it out on the floor underneath the bed and up the wall and grounded it. Now they weren't able to get down below 1,000, but they went from 5,000 down to about 1,500 just by doing that. And that was the best that they could do in their particular situation. But that was a significant improvement. I mean, we take what we can get. So, sometimes you can't get down to 100. But being in 1,000 is much better than being in 5,000. So you do what you can do.
I noticed I didn't get a clip in my BVK kit.
If you get one cord, the kits come with one cord, and if you order a second cord, because if you need the cord for the body voltage kit, so you can't use it to ground and then measure because you don't have a ground cord. So you can buy additional grounding cords for grounding a bed frame. If you're sitting at a metal frame office desk, sometimes just by grounding the metal frame of the desk that you sit at can make a significant difference. Again, the field follows the path of least resistance. And instead of going through you to ground, it's going through the cord to ground. So just by doing that sometimes, without doing anything else, we can reduce somebody's exposure sitting in their chair. They hold the meter. All I do is ground the desk, and the body voltage drops from 3,000 down to 900 or something, just because we've grounded the desk. So anytime you order an additional grounding cord, we're at 50-foot or the 12-foot ones, they come with an alligator clip.
And we have our fuse box our garage is adjacent to the bedroom. And so our fuse box is set in the wall. Could you just put Mylar up on the wall in front of where the fuse box is?
Yes, absolutely. If the fuse box is in a room that is occupied, that you're using, not a garage or a basement that you go into for a few minutes a day, yes, you can either use the Mylar, you can use the metal mesh screen, you can use the aluminum foil. I recommend you, again, if it's a room that you're occupying, aesthetics are important. So you can get a picture frame and hang the poster, put metal, the Mylar, either the Mylar or the Reflectex or the aluminum foil behind the poster, and just hang the poster over your breaker box. And then again, if that'll stop any RF from coming out of there if the smart meter is on the other side of that. And then you want to ground it so as not to increase the electric field if that is a room that's being occupied. And again, you can tell you can ground it and take a reading before, see what the reading is, put the alligator clip on it and ground it and see if it improves the electric field. So then this gives you the feedback that you need to make an informed decision, because sometimes we do things and it makes it worse. It's like, oh, who knew? Well, you now know, because you can measure it, and everything that you do, you can check to see if it's improving the situation or making it worse. This empowers you to be in control of your environment from an EMF point of view.
So
Now,
you basically would have just the wire running from the picture with the Mylar behind it down to the outlet into the ground.
correct. Check the circuit, clip the crocodile clip on the Mylar or the aluminum foil behind the picture, and then run that to ground. And again, test to see if that's helping or not helping. Now, let's just say that your smart meter is on the other side of that wall. It's on the outside wall. The panel is on the inside wall. Maybe it's a converted garage, so you're occupying the space. Now, what a lot of people do, they get the metal mesh and they put that screen, they sell them online, covers for smart meters. But if you put that on the outside of your house, that's protecting your neighbors. That's protecting everybody outside. It's actually reflecting more of the radio frequency back into the house through the wall. So by putting one of those things on the outside, you could be increasing the radio frequency on the inside. Does that make sense to people? Because this act to radio frequency, it's not just blocking it. It's not absorbing it and taking it to ground. It's reflecting it back. This is like a mirror to light. So if you put up a screen on one wall, it's blocking everything from coming through it from the outside, but everything coming from the other side is bouncing off of this, just like light does on a mirror, and coming back in. So again, you have to use it very carefully. And if you've got a smart meter, you want to put the screen on the inside to stop the RF from coming into the house. You want your neighbor's smart meter, which is 6 feet away, if your houses are that close and they've got a smart meter facing you, you want them to have the screen on the outside of their house to protect you. But what I recommend is if you've got a fence between you, just put up some metal mesh on the screen, because you can't see it when you stand away. You can't see it. So if you've got the metal mesh on the fence between you and your neighbor, any RF coming from them, is going to be significantly reduced and not come into your house. So that's, again, another tip that we use. You can put the metal mesh screen on the outside of your house, on the fence, just between you and a known source of radio frequency, which is your neighbor's Wi-Fi router, or if you've got a tower in your neighborhood that's close by. I wouldn't worry about it if it's half a mile away, but if it's a few hundred feet away, you definitely need to, be thinking about some kind of shielding for that. Okay, let me just check the chat here. Can you put screening under the mattress rather than the floor? You can, but if your mattress got springs in it, I wouldn't. I'd put it on the floor. And if you've got a metal frame and you've got springs in the mattress, you want to get the grounding cord, the alligator clip. And if you can find the metal in the mattress and clip directly onto that and ground that, because the coils can act as antennas for radio frequency, and they will pick up electric fields. So I would put that on the floor. But yeah, you can put it underneath the mattress. But I would highly recommend, if you have a metal coil mattress, trying to ground the mattress by finding a piece of metal. You may have to cut a little slit in the side of the fabric and then clip the alligator clip onto one of the pieces of metal there, and ground your mattress. And again, test with the meter and see if that helps or not. Linda, you said you have a question. Did that get asked yet?
No, I have a question. I've got light switches that have hardwired, like a little night light inside of the switch. So you can't turn those off. Are those creating more EMFs then?
Well, if it's an electric field, you just measure. I mean, you just measure and find out. I mean, some of these devices don't put out hardly any electric fields, and others put out a great deal of electric field. I mean, you can turn off that circuit. If you need a night light, then just get I don't have one here. You can get little night lights. This is actually a battery operated, so there's no electric field being put out by this.
if the wiring is going to that switch, and it's actually creating, a little light in there, that because the electricity is getting, the voltage is getting smaller, that it's actually creating more EMF.
No, actually, no. The thing about electric fields, if you can have a circuit running through your house with nothing turned on. So there's no current. You only get current when you turn something on. So that can increase the magnetic field, but the electric field is in the wire, whether there's anything plugged into that circuit or not. Just the wire in the wall that's a live wire. It's got electricity in it. It's putting out a field 6 to 8 feet. You plug in a light into that circuit, it's not going to increase the electric field. So the lights in those plugs or those switches is not increasing it might increase magnetic field, but it's not increasing the electric field, and it's not going to be creating any RF. But if you kill that circuit and you get an LED light like this, and have this by the side of your bed, and if you need a light, you just push the button and the light comes on. You go to the bathroom, you can move around and do whatever you need to do. So you can have those circuits off if the wire running through the wall is causing a problem for you in your bed area, because you want to say have as low EMF as possible at night when you're most sensitive. When we only heal at night. So those of you who've come from the detox group, your body is trying to detox and heal at night. And the less interference your body has, the more efficient and effective that healing process is going to be. We have lots of testimonies from people who suffer from EHS, and they would have to plan going out to the store. They had 5 minutes. They could go into the store. They had to get in and get out within 5 minutes, drag themselves home, and then literally took them 2 days to recover. After they got the EMFSafe switch and they created an EMF mitigated sleep sanctuary, they could go out, spend a couple of hours out, come home, maybe sit down and relax for a couple of hours, and then they were back to normal, and made a huge difference in their lives. And that's by having created an EMF mitigated sleep sanctuary to heal in. And so instead of getting a little bit worse every day, their body was able to recoup and recover, and they had the energy to actually improve their situation to the point that after a few weeks or a few months, they were able to function somewhat normally, significantly better than they were before. It makes a huge difference. Can a lamp that is unplugged still give off EMFs? That's an excellent question. And the answer is yes. Let me explain. When I first got into this, I had a bedside lamp on a metal rod by the side of my bed. And I did all this reading. I didn't have any meters yet. I was first getting into this. So I unplugged the lamp by the side of my bed. And I thought, okay, problem solved. But unbeknownst to me, there was an extension cord running down by the side of my bed, which was touching the metal base of the lamp. And when I got my meters and I measured, I was shocked to find out that my unplugged lamp was still putting out a significant electric field. And the electric field was being induced from an insulated wire, a power cord, that was touching the metal base of the lamp by the side of my bed that was unplugged. But that field was being carried up the metal stem of the lamp. And so 12 inches from my head, I've got this electric field radiating all night long. And when I moved the extension cord away from the lamp, so it was no longer touching it, I got zero electric field from the lamp because it wasn't plugged in and it wasn't picking up an electric field. This is why metal bed frames and metal frames to your desks, because if any part of that metal desk or your metal bed frame is in an electric field, it's going to pick up that electric field and carry it through the whole metal of the bed frame, the desk. Just like my lamp, which wasn't plugged in, because it was touching an extension cord that was plugged in, I was getting that field right by my head. So that was how I learned the hard way that what you think is doing the right thing may actually be making things worse. And it wasn't until I got a meter and I was educated and getting the feedback that I needed that I could fix the mistakes that I'd made. Unfortunately, most of what I did was good, but there was a few things I did actually made it worse. So that's why the body voltage kit and a Gauss meter for magnetic fields and an RF meter is so important when mitigating. But the number one thing to do is to create a sleep sanctuary, and you only need an E meter, a body voltage meter, to do that. Because when you turn off those circuits that are affecting your bedroom area, when you turn off those circuits, disconnect them at the breaker box, there's no electric field, there's no dirty electricity, which is a component of the electric field. If there was any magnetic fields on that circuit, that's gone bye-bye because there's no electricity in the wires anymore. And any RF on those circuits from any smart devices connected to them, maybe you've got a flat screen TV on the wall that's plugged into that circuit. So that RF, Wi-Fi, Bluetooth that's being broadcast all night long, even though that's not turned on. If you've got a DVR, it's broadcasting all night long, whether it's turned on or not, the Apple TV and all those things. So when you kill that circuit, you're taking care of the electric field, the dirty electricity, magnetic fields, and RF on those circuits. And that's why we say, just with a body voltage kit, you can set up a sleep sanctuary. Now, for the rest of the house, and to find out whether you need to do shielding because you're in an apartment situation, a Gauss meter and or a RF meter is definitely the next step up to deal with that 30%. Having dealt with the 70, you can do this. And for most people, that's enough. But if you want to take it to the next level, then absolutely get an RF meter and a Gauss meter for the magnetic fields.
I have a question. Can you hear me?
Yes, I can.
If you have a wooden bed, but it's got metal screws in it, I mean, you can find beds that are totally wooden, but they're pretty expensive. And so would the metal screws contribute significantly to the issue?
No, just a screw. They're isolated. They're tiny. You know, they might be picking up something, but nothing of significance. And the whole point of turning off the circuits is you're removing the electric field, the bed and the springs, and if you've got a metal spring mattress, by turning off the circuits, there is no electric field to be induced into anything metallic there anyway.
Okay, thank you.
So yeah, I wouldn't be overly concerned about wooden metal screws in a wooden frame bed. It's just the metal itself can pick up, because it's very hard to get down to zero. As I said, when somebody says, you know, I turned off the circuits and I got zero, I said, then there's something wrong.
Okay,
Yeah.
thanks.
Yeah, you're welcome. Anybody else got a question?
Anthony, so I get the shielding part of trying to do that in your house. And actually I have a question. I'm very reactive in my garage, and when I step into my garage, I've got my dryer on the left and furnace and hot water heater straight ahead. Can I put insulation on the sides of those to protect the garage, or even on top of the electrical panel?
Yeah, you can buy some of this. It comes it either comes in 2-foot wide rolls that are 10, 20, 50, or 100 feet long. It comes in 4-foot rolls. So if you were to if you got your water heater here and you just stand this up in front of the water heater or the breaker panel or anything else, and then put the alligator clip on the corner and ground it, measure and see what difference it makes.
So you would need a alligator clip for every different shield.
If they're connected, one will do. But if you've got one over here and another one over there, they would both need to be grounded. Yeah. Because you're trying to get rid of the electric field. I don't think you're getting RF. If you walk into the garage and you're still 8-10 feet away from those devices, It's not a magnetic field. When you measure magnetic fields, they are normally only 1 to 2 feet away from the device, and then they drop off to insignificance. My business partner has got a transformer. The neighborhood transformer is in his front yard, and I measured that, and I have to be like 3 feet away before I get an electric field reading from it. Shock to me. And I don't get a magnetic field reading until I'm 2 to 3 feet away, and then it just goes off the charts. But if I'm 4 feet away from it, there's no magnetic field. So you can get a magnetic field and an electric field from your breaker panel. And then the shielding will, if that's a room that you occupy, maybe you're going in there doing work or whatever in your garage, that can significantly reduce your exposure by doing that. It could be any number of reasons. It could be circuits. Unlikely there's circuits in the floor of a garage, but it could be the lights. It could be, if you've got a garage door opener, that could be not grounded. And so it's got power in there. And if you get your pen, you turn it on, and you get it. If you go into a kitchen, anybody's kitchen with fluorescent lights, and you turn the pen on, normally at head height, it's going off. You get down by your waist, it goes off. If you've got a high ceiling, like not an 8-foot ceiling, but a 10-foot ceiling, you put your hand up and the pen starts going off, because that's the radiation electric fields coming off of those lights. And it could be the same in your garage. Maybe that metal frame that is the garage door, that the garage door slides on. And so again, you would get a crocodile clip it on the metal frame somewhere, alligator clip, crocodile clip, sorry, clip that on the metal frame and ground it. And then you can measure, see if the field's gone away or not with the pen, measure it with the meter. And instead of when you step into the garage, you've got to check your body voltage, see what it is. If it's 1,000, 2,000, and then you ground the metal frame, or you put the Mylar up, and instead of being 2,000 millivolts when you step in, it drops down to 1,000 or 500. You've taken a step in the right directions. You don't want to ground yourself. Now we're going to get controversial. A lot of people are into grounding. They have grounding pads on their beds. And if you have a grounding pad on your bed, let's say it's down by your feet, not grounding sheets. If you're getting a reading of 2,000 millivolts laying in your bed before you turn off circuits, and you put your foot on a grounding pad, so this is on the foot of your bed and it's grounded, your body voltage is going to go down to 0, because you're double grounded. Because the way the body voltage kit measures is it's giving the field that you're in a path of least resistance to ground through the meter so that you can measure it. But if I put my foot on a grounding pad, my body voltage meter is going to go to 0, because now that electric field has a path of least resistance, less resistance than the meter. I'm still in 2,000 millivolts. The electric field that I'm in has not changed, but the meter says 0 because I'm double grounded. This is the mistake that people make with grounding. When they're sitting at their desk, they get a body voltage of 2,000, 3,000 millivolts from the computer and the printer and the screen. And they get a grounding pad and they put their foot on it, it goes to 0. They think they're fixed. They think they've solved the problem. No, they've just made themselves part of the circuit. Imagine birds on a high power line. They're fine. But if you ground one, you've got a cooked bird. When you ground, you're making yourself part of the circuit. Now that 60 hertz AC electric field is flowing through your body all the time. Okay, let me read this. Jen, what does it mean when the body voltage reading goes up after cutting the circuit to the bedroom, as well as when cutting the circuits to the surrounding rooms? In one of our rooms, the reading gets higher after cutting the circuit. Okay, yeah, this is an interesting situation. So what happens is exactly like my lamp by the side of my bed, which was unplugged, was picking up an electric field because there was a power cord running next to it. What can happen is circuits running through the wall, the Romex running side by side in the wall, they can either activate each other or neutralize each other. So sometimes you get a reading, and when you turn off one circuit, the field from this one is increased and the reading goes up. And that has to do with you've got two poles coming into your house, 120 and 120. And when you've got those breakers on your panel that are joined together, there's two switches which are joined together. That's a 240 circuit. So you've got both legs combining to make a 240 circuit. Now, all the circuits on your breaker panel, as you go down the panel, you've got all the odd numbers on one side and all the even numbers on the other side. But number 1 comes from the left-hand side and number 3 comes from the other side. Number 5, number 7, number 9, number 11, as you go down the panel. That's that way you can have two breakers next to each other that create a 240 circuit, one from the left, one from the right. So if you turn off a circuit from the left and you're measuring a circuit on the right, the field can go up. So we're looking for the magic combination of circuits that are turned on and off to get the lowest possible reading. And it is counterintuitive, but sometimes we turn on circuits and the reading goes down. And for the reason I've explained, and that's controversial in and of itself, because we've got electricians and experts in the field that have been doing this for years, and they disagree on the reasons for this happening, but it does happen. So you're going to turn off the circuit to your bedroom. Almost always, that's the one that needs to be turned off. And if you turn off a circuit, it goes on. Some goes up, then turn that circuit off. So you're just going to look for the magic combination for you in your situation to get the lowest possible reading. And that might take a while working with somebody by the panel. You're in bed or somebody's in bed with the meter reading, and you're just going to keep flipping things on and off until you've got the lowest possible reading. And it's bizarre. It really is strange that when you turn something on, the reading goes down, and sometimes when you turn something off, the reading goes up. You're looking for the lowest reading. So excellent question. Thank you for asking it. Diane, hi. Will a DE add onto the EMFSafe switch? Hang on. Oh, will a DE add-on? Okay, that's a PQ filter on the safe switch panel help with mitigation of a smart meter in our crawl space? Will it mitigate the surge every 4 seconds or so that the smart meter creates? I was told smart meter in the crawl space sends a surge to our whole electric grid. Okay, there's different types of smart meters. There is a particular system. So Diane, when you say it sends a surge, are you measuring that surge with the body voltage meter or with an RF meter?
I believe it's an RF meter.
Basically, I can't imagine why. I mean, a smart meter is nothing more than a meter, a dumb meter with a built-in cell phone. So normally what happens is they connect once a day at night for 2 or 3 seconds. Sometimes some systems, some electrical companies, they send a message home every hour. I can't imagine why it would be on all the time. But if you're using an RF meter and you're getting a ping, then that's an RF signal. If it's a surge, and we see this with Tesla power walls and chargers for electric cars, you get a dirty electricity surge, and the dirty electricity is doing this all the time.
Yes, I think that's what's happening. Yeah.
That doesn't show up on a this doesn't measure dirty electricity. Dirty electricity is like 1 or 2%. We're concerned about the 60 hertz, because if you kill the 60 hertz, there is no dirty electricity. So we're killing 4 birds with 1 stone by turning off the circuit. But if you've got a smart meter and it's sending out, it's pulsing, if it's a dirty electricity thing that you're picking up on, yes, the PQ filter on the mains is going to significantly reduce, again, no such thing as zero, significantly reduce. We're seeing a drop of 80% of dirty electricity coming into your house. which will be picked up, and you could read that on all the circuits in your house because it's part of the electric field coming in from the outside. Your smart meter is contributing to that. The RF signal can be blocked by covering the smart meter so that the shield is between the living space and the meter, so that you're on this side and smart meter's on this side. So if it's under the floor, just put this over so that the smart meter's underneath and the signal isn't coming up into the house. So RF is stopped by this. The dirty electricity can be significantly reduced with the dirty electricity filter, the PQ filter that we have. And then there shouldn't be any electric pulse coming in. Now, if you have what's called the TWAX system, there is a TWAX system which doesn't use RF. They're not sending out a radio frequency signal, which again is nothing more than a smart meter. And everybody's worried about smart meters because they're putting out an RF signal. It's no different than the 5 cell phones in your house. Your cell phone is far worse than your smart meter, because your smart meter's 10, 20, 30, 40 feet away, and you can shield it. The cell phone in your hand is doing far more. You're getting far more exposure from your cell phone. You're probably getting more exposure from your neighbor's cell phone than you are from your smart meter. Anyway, but the TWAX system uses a low frequency pulse, very close to 60 hertz, a low frequency pulse that rides on the power line. So they're reading all of their meters and they're picking up that signal on the power line. It's part of the electrical system coming into your house.
Okay.
They're used in rural areas because that low frequency, the RF, is hard to pick up because houses are so spread out in rural areas. But the TWAX system rides on the electric circuit, and there's nothing you can do about it. You can get rid of your TWAX meter and all of your neighbors' meters. You've got 200 meters in your neighborhood. All of those signals are part of the electricity coming into your house. And to date, there is no meter that will filter that out because it's so close to the 60 hertz electric field to begin with. We can't filter it out. It's just there. So even more reason to turn off the circuits in your bedroom at night. And maybe if you're that sensitive, in your office space, and bring a extension cord in from the outside and have as little 60 hertz AC exposure as possible. Use your iPad on battery, use your laptop on battery, and not have that 60 hertz field. Have the printer that's plugged in, have the circuit in your room turned off, work in there on your laptop on battery. You don't have an electric field. If there's no electric field, you're not being affected by that TWAX signal, that low frequency signal, or the dirty electricity that's part of the electric field. So again, for sensitive people, we have to take it to the next level. Most people, it's not a problem. You create a sleep sanctuary, reduce your exposure by 70%. For most people, that makes all the difference in the world. Sensitive people, we have to take it. That remaining 30% is an issue, and we have to get rid of, the next 10, the next 10. Again, 100% is almost impossible, but if we can get you up into the 90s, there's ways to do that, but it gets very expensive too.
Yeah, we have someone who is very sensitive, well, a couple of us, but was not able to get his body voltage below 0.252.
That's 250 millivolts, yeah. And
Yeah.
the goal is below 100. And for sensitive people, 30 or 20, if at all possible. That's when we start taking it to the next level. But with everything turned off, you say you couldn't get it below 250 millivolts?
Mm-mm.
Is that a detached house or an apartment or a duplex?
It's a detached house.
Wow. And you turned off the power to the house and you still had 250?
With completely, like when we had a power outage from the like it was shut down the whole neighborhood from the electric.
That's a
Yeah.
pretty good indication. Yeah.
Yeah. It was, his room was 0.033.
That's 30 millivolts, 33 millivolts. Okay.
Mhm. So
Where's it
then,
coming from?
we-
That's weird. This is one of the weird things that, when the power grid's off, so you're
Yeah.
not getting anything from your neighbors. There's nothing in the ground. Why is there even 33 millivolts there when the grid's off? I don't
Yeah.
know the answer to that question, but
other parts of the house were at the 0. So that's why there's something about that room.
wow.
Well, does the screening, like the Reflectix, is that something that I would look at to try and help bring that down since he's so sensitive, or is there
Well,
other things we need to look at?
you can use the pen and see if it goes beep, you've got a field, and then you need to find which breaker that's coming from. I don't understand why with the grid down you'd be getting a reading at all. That's an odd one, but if you can find the source of the field, and you can do it with the pen or with the meter, and just walk around, and then you can just touch the wall, and if the reading goes up, then the wall is picking up. And I've seen that in some houses, the whole wall is like live.
Yeah.
Maybe there's insulation in the wall, and that insulation, which is metallic, is not grounded properly, and it's picking up a field from somewhere else in the house. And so that whole wall in the living room, you put your hand on the wall, and the reading goes up. One of the things you can do is put a screw into the wall so it's connecting to the sheetrock that's got the aluminum foil on it, which is part of the insulation to the house, and then clip the alligator clip onto that screw, and see if that and then ground it, and see if that helps. So there's all kinds of things that we do in situations like that. If you've got if the box that the plugs are in are plastic, then you can't do this. But if they're metal, then you can clip a alligator. They should be grounded. So you can clip an alligator clip on the metal. Be very careful not to touch a live wire. You got to be careful doing this stuff, and see if that makes a difference. So there's different things that we can do. But again, when you start opening things up, exercise extreme caution, please.
Mhm. Okay. Is there some way we could work with you to figure that out? Because I don't know.
Yeah, we fully support the body voltage kit and the EMFSafe switch. We do that for free,
Okay.
with the manufacturers of the product. But if you have other problems and issues, beyond, product support, we are available to consult for, 10, 15 minutes, half an hour. I mean, if you want me to help you do the mitigation, you're taking the readings, we're on a Zoom call or using Skype or something. If you want me to sit with you and hold your hand for an hour, I'm more than happy to do that. But that's not product support. That's EMF consulting mitigation, and we do charge for that. But yes, we are available, and using us remotely can be a lot cheaper than we do work with building biologists and EMF consultants around the country, but sometimes there isn't one close to you. If they're 2 or 3 hours away, it can cost you $1,000 to have one come in for half a day. So if that's your choice, yes, we are available for consulting to do things like that. But we support the body voltage kit. This is a free call. If your electrician is hooking up the cutoff switch and they have questions, just call us. I mean, we fully support our product. So
Yeah, the electrician we talked to wants to charge $1,500 to install the sleep.
where do you live?
Indianapolis?
That is ridiculous.
Okay.
They want $1,500 to install what?
Yeah, the safe switch, the EMFSafe switch.
How many circuits are you cutting off?
We didn't even get to that. I mean, we have to turn off a lot, and still not getting to where we need to be. So,
if you've got 8 circuits to turn off, an NP8, you're looking at 3, possibly 4 hours of work.
okay.
Call another electrician, ask them what their half day rate is, which would be for 4 hours,
Okay.
Say, what's your half day rate? What do you want me to do? Well, we've got a box we want you to install. You can send them to the website. They can go on the install page and it gives you a video there. It shows how easy it is to install. $1,500 is absolutely ridiculous.
Okay. I think it
Unless
might be
you've got
more than
other-
eight switches. Does that make a big difference?
Say again?
I think it's probably more than 8 switches. Will that make a big difference?
Well, yeah, the more you've got, obviously it takes twice as long to hook up an NP8 than an NP4 or an NP2. I mean, if you've got 2 circuits, it's a lot quicker than 4 circuits or 8 circuits.
Okay.
But still, I mean, ask him what his day rate is.
Okay.
I mean, if he's charging $1,500 a day, you find somebody else.
Okay. And it does have to be someone licensed, right?
We have to tell you yes, because we're
Okay.
UL licensed. If you've got a handy dandy friend who's worked on electricity, they know what they're doing. If you want to do it yourself, homeowners legally are allowed to do it themselves. We tell you you need to use a licensed electrician.
Yeah.
Whether you do or not, it's entirely up to you.
Okay. Okay. Very good. Thank you.
So another we have a static Jen. Hi, we have a static whole house filter by the power box outside of the house. Would it also be beneficial to have a DE filter for the power box in the garage? So when you say power box, you're talking about you got 2 breaker boxes. So you got 2 breaker boxes. Are they both connected directly to the? Are they both primary boxes? Or is one a sub panel of the other? The one in the garage is a sub panel. Where are the, are you wanting to cut off circuits as well with an EMFSafe switch? Okay. And where are the circuits that you want to cut off? Are they on the sub panel or are they on the main panel? They're on the sub panel. There might be some advantage if you've got a static whole house filter on the main panel, that's going to filter the stuff coming in. They're less affected on the sub panels, but they will have some effect. So what I would say is measure the, do you have an EMI meter to measure the dirty electricity? Okay, so when the static is hooked up, what dirty electricity reading are you getting on those circuits that are coming from the sub panel? Varies between 1,000 and 100. A second, if you buy the EMFSafe switch, I would not recommend the PQ2 because dirty electricity is really weird. And when you get too much capacitance, which is how these things work, they can actually become less effective. So if you're getting readings of 1,000 still with the static, I would say, and the circuits you want to cut off, which is where the EMFSafe cutoff switch with the built-in filter, if you get the built-in filter, is going to be right next to the sub panel. So having the PQ1 would probably help reduce the dirty electricity on those circuits, because the fact that it is a sub panel removed from the main panel, the filter, the static filter is, same thing happens with ours. I'm not speaking against the static. Our cutoff filter and the static filter are very, very similar. Ours just happens to be half the price. So we actually get slightly better results in a variety of different situations as tested by independent engineers. So the fact you do vary between 100 and 1,000, it depends upon what you've got turned on as to what your readings are. So if you have solar panels or anybody else has solar panels, then when they're active during the day, you're going to get a completely different DE profile, different frequencies, than when they're off in the evening, when the sun goes down and people come home and they're plugging in their cell phones and their laptops to charge them up. The switch mode power supplies of these things is creating dirty electricity, and it's a different frequency. So that's why sometimes you get 1,000 and sometimes you get 100. And in the variety of circumstances and situations throughout the day, the difference between daytime and nighttime DE, and between winter DE with the heater running and summer DE with the AC running, we got the best results, and we're also half the price. But the Static's a great product. Under normal circumstances, if somebody has a static filter, I say then don't buy ours, because it can actually work against you. But in the case of a sub panel, there might be some advantage for you in doing that, to answer your question.
Anthony,
Yeah, go ahead.
can you talk a little bit more about the cutoff switches? I don't understand them. I have pictures, but do those go on the fuses in the fuse box?
Okay, so our cutoff switch, which you can see on the website, there's pictures of it all over the place. Our box, which is either for the one circuit, it's a 12 by 8-inch box, and it's 4 inches deep. Our other units are either a 12 by 12 box, a 12 by 18 box, and the EMF safe cutoff switch for 8 circuits with a built-in filter is 24 inches. So that box either goes on the wall or in the wall for a flush mount right next to your breaker panel. So the circuits that are being cut off, our cutoff switch goes right next to that panel. Now our panel comes with a pigtail of wires. It's fully assembled, ready to go. If you're out in a garage or laundry room or something, the quickest and easiest installation is to just put it on the wall. It's only coming out 4 inches. Obviously, if it's a room that's being used, you want to sink it in the sheetrock, and it takes a little longer. So keep that in mind as far as installation goes. Then our pigtail of wires goes through into your breaker box. Now, the circuits that you want to disconnect, the electrician pulls out the wire from the breaker. He connects it to a wire that's come from our switch that goes to the relay. Then the other wire from the relay in the pigtail of wires is put back into the breaker. That's all he's doing. He's pulling out a wire, making a connection, picking up the other wire, and putting it back where he took the original wire. That's all it takes to install an EMFSafe switch. He's going to do that for a NP2 for 2 circuits. He has to do that for the neutral wire, and he finds the neutral from that circuit, does the same thing. That's 2 connections. The power for that's 2 connections. So for every circuit, there's 4 connections to be made. An NP4, he's got 4 4s of 16 connections, plus the power and the neutral for the EMFSafe switch. So that's 4 4s of 16, 17, 18, and the ground 19 connections, 20 connections if it's got a filter built into it. He pulls out a wire, makes a connection, takes another wire, puts it back in, tightens down the screw. He does that 20 times. That's not $1,500 worth. If he says that's too complicated, I can't do that, then I highly recommend your electrician considers becoming a plumber, because this is electrician 101. It is so simple. It's a 2-hour, 3-hour, an NP8, possibly 3 to 4 hours. If he has to cut into the wall, that takes more time. It's the simplest thing in the world. But to answer your question, it goes right next to, our box goes right next to the breaker box, and then those wires are fed in and those connections are made. And that's it. If you have a two breaker panels and they're both in the garage or they're side by side, and you've got circuits in both of them, we can do that with one EMFSafe switch. You can have 4 from one and 4 from the other, or 3 from one and 5 from the other with an NP8. But if the sub panel is on the other side of the house, and you've got some circuits in the main panel and some circuits in the sub panel that's 50, 100 feet away, then you're going to need 2 cutoff switches.
And I also looked on the website, and I didn't see the additional grounding cords with alligator clips on there. On the
If
menu.
you go to the BVK page, it's in a drop down.
Okay.
One of the drop downs says, would you like an additional grounding cord, and it gives you the option to buy one or a packet of 3, and you obviously get a discount for the 3, and you get a discount off of 1. Then you can go to the website and just buy the alligator clips, and again, you can buy 1 or you can buy 3, and that's on either the special. I think it's on, if you click on the extras, I think you can buy the clips by themselves without a BVK, but on the BVK page you can buy a BVK with extra grounding cords, and I think if you go to the extra page you can buy the grounding cords by themselves. Okie dokie. Anybody else? Still got 3 hanging on here. Thank you very much. Appreciate your hanging with us. I hope I've been answering all of your questions, and would like to hear from somebody quickly who has received a body voltage meter they've measured and they were amazed at what they found. We love to hear back from people in the field. Or how you felt once you started turning off the circuits. We have people who, I've got calls from ladies that said, my husband stopped snoring last night for the first time in 7 years. Thank you so much. People wake up in the morning after they get an EMFSafe switch put in, and they wake up in the morning and, we get a tearful phone call saying, I didn't have a migraine for the first time in as long as I can remember. Thank you so much. I mean, stuff like this it's why we do what we do. So it's wonderful to hear from people.
I just want to say thank you so much. This has been, I've got a long ways to go, but you've given me lots of ideas of places to check and things to read. I know I can reduce things, and using that reflective shield will probably help too. Should we test that first? Like, should we buy it and tape it on the wall and test it before we install it?
Well, of course, yes.
Yeah.
What's the situation you're trying to shield?
A refrigerator that I suspect if we shield it, then I'll have less voltage in the bed.
So you've got the
The back of
refrigerator,
the
a
refrigerator.
wall, and then your bedroom is on the
Yeah.
other side.
Exactly.
Yeah, that's probably going to help. Absolutely. If you buy a 4-foot roll that's just the shortest length you can buy, just put it up behind the bed. It stands up by itself. That's the nice thing about this. It's easier to work with than the metal screen, but again, it depends upon the situation as to what people want to do. But put it up there. You might even just try aluminum foil.
Uh-huh.
Get some cardboard and some aluminum foil, or just get some Scotch tape, aluminum foil on the wall, ground it, see if that works. And if that's, too ugly for you and you want to do something a little more decorative, then the mylar or the metal mesh. But yeah, you're only going to do a permanent installation if it improves.
The refrigerator is kind of in a cove, so I'm figuring just to do the mylar or foil the same size as the refrigerator, so it wouldn't show. Or does it need to be bigger than the refrigerator?
Well, the circuit for the refrigerator is in the wall, so that's more reason. If you want to shield yourself from the turn off the circuit to the refrigerator, and then take a measurement.
Yeah.
So it's not the refrigerator. It's not the refrigerator. So I want everybody that's left on the call to do this. Get your body voltage meter in the kitchen, plug in the ground cord, and stand next to your refrigerator and see what the reading is. Now touch the refrigerator. It may not work for the door. If it doesn't work when you touch the door, touch the side of the refrigerator. There's a 99 times out of 100 chance your body voltage will go down to 0. That's because the same thing is happening that happens with a grounding pad. Your refrigerator is a metal box that is grounded. So when you touch the refrigerator, your body voltage will go to 0 because you're double grounded. Because now the electric field that you're in, 1,000, 2,000, 3,000 millivolts standing in the kitchen, instead of going through the meter to ground, that you can measure it, it's now going through your other hand to ground, avoiding the meter. So the electric field that you're getting in your bedroom is not coming from the refrigerator, it's coming from the circuit going to the refrigerator. So you want the shielding on your side of the wall for that reason. I go into details about explaining the principles behind what's going on, because once you understand the principles, I'm not buying you a fish dinner, I'm teaching you to fish so that you can apply these principles in a variety of circumstances and situations. Because once you understand the double grounding principle, 1 and 1 makes 2, and you can go, oh, okay. And you're also equipped to help your friends, which I sincerely hope once you've mitigated your house, you've got friends and neighbors and things. And if they're having symptoms, you say, well, hey, maybe it's EMF. And they're going to go, what are you talking about? And then you pull out the pen and you point it at their toaster and it goes beep, beep, beep. And then you hold it in your hand and then you touch the toaster and then you hand it to them and you hold their hand and you touch the toaster and it goes beep, beep, beep through you, through them. And all of a sudden you've got a convert and all of a sudden you've got their attention and you say, well, hey, just turn off your circuits for a few nights, see how you feel. If you start to feel better, if it's not caused by the EMF, you know the EMF is contributing to the problem. And if you mitigate the EMF, you're going to start getting better instead of getting worse, because by turning it off for 2 or 3 nights, you started to get better. Why not turn them off permanently every night? Give Anthony a call at EMFSafe, buy a body voltage kit. You can measure yourself, get a safe switch, and be on the road to recovery. I mean, you know, you guys are out there working for us, I hope.
Thank you. So I should put the foil inside the closet that is then on the other side of the refrigerator, and then the bed.
How far is your bed from the refrigerator?
Well, my head in the bed is probably 9 or 10 feet. My feet are probably only about 4 feet.
You might be picking something up. The way to tell, as I said, is take a reading, find the circuit to the refrigerator, turn it off. If your body voltage drops, you know that that circuit is contributing to your reading.
Yeah. Okay.
If it doesn't change, you need to look for something else. You don't need to go to that expense. It's coming from somewhere else. And then, as I said, you can take the pen and find other live circuits in there, or just manually go through the breaker box until the reading drops. And then you identify which circuit does need to be turned off. But you know, it's not a problem to turn off the refrigerator. When the power goes out, you have a power outage, the electricity can be out for 6 to 8 hours. The freezer doesn't defrost. A freezer runs at minus 15 degrees centigrade. In 8 hours, it probably goes up from 15 to maybe 12 or 10. It's still frozen solid. It doesn't defrost overnight. Your refrigerator runs at 4 degrees centigrade. It might go up to 7 or 8 degrees centigrade. You can turn off, get a thermometer, take the temperature at night, turn off the circuit, turn off the refrigerator, and then go to the refrigerator in the morning, open the door and see what the temperature is.
Okay.
There's a good chance if you're in a situation like that and you don't, you know, for people who don't want to turn off the refrigerator because maybe you've got an old one and it's not that well insulated, but the new ones are much better than the old ones in that regard, again, depending upon the make. But it's not that big a deal to turn off the refrigerator. Actually, if the head of your bed is, and you have no choice, you can't move the bed, and your head is 12 inches from the refrigerator, the electric field is not so much the problem as the magnetic field. When that refrigerator is running, you're getting a magnetic field. That's a much bigger concern. If you're 4 or 5 feet away, it doesn't matter. It's not affecting you. But the electric field from the refrigerator, the circuit going to the refrigerator, not the refrigerator itself.
And the body voltage kit measures the electric field, not the magnetic field?
Correct. We're only measuring electric field with the body voltage meter, because when we're trying to find circuits to turn off. Our number one job, our number one goal, our mission is to locate circuits that are affecting you and turning them off. When we turn them off, when you turn off your circuits, you're killing the electric field, you're killing the dirty electricity, you're killing any magnetic field on that circuit, and you're
Oh.
killing any RF coming from that circuit, be it a smart TV, you know, a Wi-Fi router or anything else like that. So we don't need to measure those things to create a sleep sanctuary. Now, if you want to mitigate your office or the rest of your house, that's a different situation. If you've got if you're worried about RF in addition to, because you know there's a smart cell phone tower close by, or your neighbor, even in a detached house, especially in a condo or an apartment building, then getting an RF meter is a really good idea. And that's where we take it to the next level, having turned off the circuits and dealt with the electric field and the RF in your house, turning off your Wi-Fi router. But now we need to worry about your neighbors. That's where shielding comes in. That's when we take it to the next level in those situations. Yeah.
Thank you.
You're very welcome. Okay, thank you, everybody. I'm going to do this again in another 2 weeks. It may not be BVK specifically related. We may just do an EMFSafe Q&A. Thus far, I've only invited people who have bought a body voltage kit. We might go back to registration because I had no idea how many people were interested in attending this until I got on the call myself. So we may do registration again. And feel free to invite friends, family that might be interested, especially if you have skeptical family members that have questions. This is one thing that can really help people that are skeptical. This is a Gauss meter. This is a magnet. So when a magnet spins, a hairdryer, an electric fan, hair dries in your hand, but it's only there for a few minutes. So, you know, but a fan all night long, you don't want it within 6 feet of your bed because that is throwing out a magnetic field as well as the electric field. But the reason this is an issue, that magnetic field is going through my body, through my brain, as is the 2.4 gigahertz from your Wi-Fi router, from your cell phone, from your Bluetooth headset. That should freak everybody out. And if you have skeptical family members that don't want to support you in your mitigation of your sleep area and their sleep area, then the pen can help and this can help. So feel free to invite them to the next meeting, which will be in 2 weeks' time. So thank you, everybody. God bless. Have a wonderful time. Have fun mitigating. And please share your testimonies and your stories so that everybody else can benefit from them as well. And if you want to give us a call, if you want to do a consultation, if you have questions, you can text or email them in, or you know, we can chat on the phone. Thank you very much.
Thank you.
You're welcome.